is all about systems of equations. A lot of this is stuff that you did see in 8th grade and probably Algebra 1, but we're going to just go through it again. These types of questions show up a lot on the ACT, and they do show up a lot on the KSA, which 10th graders take. And I do have some 10th graders, so I want to make sure that we cover it good. So a system of equations is 2 or more lines or 2 or more equations. And our whole goal for this unit is finding where these 2 lines cross. And there's different methods for doing that. Just depending on the way the equations are written, kind of tells us which method is going to be the best. Most times when we have these 2 lines, they have a common point. And these systems can be classified into 3 groups. The first group is when we have intersecting lines. What does the word intersect mean?
They cross each other.
They cross. Yep. Yeah. If I have 2 lines that cross each other, how many times do they cross? 1. So we would say that they have 1 solution. The solution is the point where they cross. So if I say find the solution, I'm asking you to find that point. What do parallel lines look like?
Up and down.
Side by side.
And not the lines.
The same length.
Well, maybe like same length.
Not necessarily.
Same thing.
I just know parallel.
Those lines are parallel.
What?
Parallel lines are lines that run side by side that never touch. They have, the lines themselves are not the same, but they do have the same slope. So those are parallel lines. And so how many solutions do they have? None. Solutions are where they cross. They don't cross each other. So no solution.
For sure we did this last year.
You did do this last year.
Yeah, I didn't know anything about it.
And then sometimes you might even be given 2 equations that actually are the same line.
They were the same length.
The same line. So when you first see the problem, you may not realize that the equations are identical, but after you do some work with them, you might realize that they actually are. If this happens, we say that they have infinite solutions.
They have a solution when we connect. Right?
Do what?
Does the solution part mean like if they connect?
Solution means they cross. So if you have 2 lines that are completely on top of each other, every single point is considered a solution. That's why we say infinite. Every single point is the same. So we're actually going to get into our first method for solving systems. First method for finding the solution is graphing. We're actually going to graph the 2 lines and find the point where they cross. Now these first 2 have been done for you, but unfortunately the little tick marks, they don't show up. So I did the best that I could there with drawing those marks, but it's enough to see. The point where they cross is this point right there. So if I'm asking you for the solution, I'm asking you for the coordinate. So you need the x and the y. So what is the coordinate of this point? 1, 3. Yep. So this point right here has an x value of 1 and a y value of 3. Number 2, I'm going to do the same thing.
I can barely see the line.
I know, I'm sorry. It looks fine when I print it.
So this one has like, oh wait, never mind.
But when it runs through the copier, it doesn't do as good. I need to go back and make the lines darker. But it's too late now. So this number 2, this point, what does that point look to be about? What coordinate?
1, 4. Negative 1.
Well, negative 1 would be my y value. What's my x value? 4. So it would be 4, negative 1.
Oh.
Because the x value is 4. The y value is 1 under the origin, which is why it's negative 1. Okay. Now these next several graphs that we're going to do show up a little better, hopefully. Alright. So now we're actually going to do the graphing ourselves. So we've got 2 lines. So let's start with this first line. Y equals 1/2 x plus 1. My y-intercept is the point that's added or subtracted at the end. So what is my y-intercept? What's my y-intercept? 1. So you're going to put a point on the y-axis, that's the one that goes up and down, at 1. What is the slope? 1/2. So just a reminder, and you might want to maybe write this at the top of your page. Slope is rise over run. The rise, the top number tells us if we go up or down. A positive number goes up, a negative number goes down. The run tells us left or right. So the number on the bottom of the fraction, if that bottom number is negative, we go left. If it's positive, we go right. So if my slope is 1/2, a positive 1 on top tells me I'm going to go what? Up. And then, don't just say over, right 2. So I'm going to go from this point and I'm going to count up 1, right 2. And do that as many times as it will fit on your graph. Up 1, right 2. Now you can also count, instead of going up and right, what you can do, and this will be necessary sometimes, you can change both arrows and still stay within the line. So instead of up, we can go down and left. So I can go back to my first point and count down 1, left 2. And see how it stays right in line? Down 1, left 2. I want you to put as many points that you can fit on your graph, not just the first two. So that's the first line. The second intercept of the second line. So I put my first point on -2. And then my slope is what? -1/4. So I'm going to put that negative in the top. A negative number on the top tells me I go what? Down 1. And then a positive number on the bottom goes right. So I'm going to count down 1, right 4. Or I could switch directions and go up and left. Up, left 4. And that point, when I did that, overlapped. It overlapped right there, which is the point I'm looking for. So my solution is the point -4. My x is -4, and my y is -1. -4, -1. Are there any questions on that? Okay, we ready for number 4? All right, my first line. What is my y-intercept? 4. So I put my point on 4. And then what is my slope? 1/3. Good. So a +1 on top goes up. A +3 on the bottom goes right. So I'm going to count up 1, right 3. Or I could go down and left. And that'll stay right in line. I'm going to start calling names. So make sure you're staying with us and not off doing something else. My second line. What is the y-intercept? Michael McKinney. -3. Good. So I'm going to put my point on the y-axis at -3. And then what is my slope? Micah? -2. And how could I make that a fraction? Make it -2/1. Good. A negative number in the denominator, or in the numerator, sorry, the top, goes down. And then the +1 tells me I go right.
Do you always have to have it as a fraction?
Yes. Down 2, right 1. Or I could have switched and went up and left. You can switch as long as you switch both arrows. So up 2, left 1, up 2, left 1. And I'm going to keep doing that at least until I hit my other line. And I should have my point should overlap.
This ink gets everywhere.
Well, alright, so what is that point where they cross? Alex Todd,
What's that?
what's the point where they cross?
-3, 3.
Negative 3, 3. Oops, good.
Where do you get the last number? Oh, like, you got the number where they cross, how do you know, like, would it be the same on the other side too?
Well, it's this point has the x value of negative 3 and a y value of positive 3. You have an x, every point has an x and a y value. For example, this is the point 3, 5. The x value is 3, the y value is 5. Let's do some more. We'll just keep doing practice.
I think we got it down pat.
I don't.
Alright, number 5, my first line. Riley, what is my y-intercept?
Y-intercept,
I have the first line.
2.
2, good. So you put a point on the y-axis at 2. And then the slope,
So if there's y-intercept, we always put it on the wall. Like,
Mhm.
okay.
the slope is 4 over 3. So the 4 on top tells me I'm going to move up 4.
Can't move up for
Well, hold on. And then my bottom number tells me I'm going to move right 3. So when I start to count up 4, I do run out of room. So this is a case where you have to change directions. So instead of going up, I go down, and instead of going right, I go left. So down 4, left 3. That's one of the reasons why I've already been practicing switching, is because sometimes you have to do it. Sometimes you have to go in the opposite direction. And this one, I couldn't do any more points. 2 points was all I could get. My second line, what's the y-intercept of my second line, Emily? -1. So I put a point on -1. And then what is my slope on the second line, Jaden? Yep, it's 1 over 3. So I go up 1, right 3. Or I could switch and go down and left. And I run into that line right there.
But we don't need to switch, do we?
Well, I prefer that you do, because a lot of times, especially when these graphs are really tiny, when you just connect 2 points, I mean, I could be off quite a bit if I just try to connect these two. So the more points you have, the more accurate your line's going to be, and you'll be more likely to get the correct answer. So what is that point where they cross? Dwayne. -3 is the y value. Yep. Look over here. Or the x value, sorry. What's the y value?
-1. 2.
-2, yep. Okay. Number 6. My first line.
Good, bub?
That was loud, and I am recording.
Oh.
All Alright, what is the y-intercept of that first line? Callie? Yep, -1. And then the slope. Dalton, what's my slope? First line of number 6.
2 over 3.
Yep. So I'm going to count up to right 3. Or I could switch and go down and left. Alright, so we're going to do this real quick. And I forgot we had to leave early, so.
What AM schedule?
PM, yeah.
PM.
Alright, hold on. We have enough time to get the second one. The second line,
Do you put the 2 over the 1, or do we put 1 over 2?
the one goes in the bottom.
Okay.
So the y-intercept would be 3. And then my slope is 2 over 1. So up to right 1, or I could go down and left. And this point where they cross is -3, -3.